So what we're going to learn today is how we can calculate the length of the hypotenuse in a right-angled triangle. Now, we recall that the hypotenuse is the longer side of a right-angled triangle. So if you have a triangle, look for the hypotenuse. Firstly, look for which side is the longest. If you can't identify from that, you also know that the hypotenuse is always going to be opposite the right angle within a triangle. So two ways in which you can identify here. If we draw our attention to this triangle over here, we're going to discover that we have a right angle triangle because it's got a right angle here. How do we know that? Well, it's just given. Now, if we're asking ourselves, where's the hypotenuse going to be? The hypotenuse is always going to be opposite our right angle. So if we identify our right angle and draw an arrow pointing outward from it, it's going to point at the side called the hypotenuse. Now, when we identify the hypotenuse, we always give it a label. We label it C. C for hypotenuse. Why C? Because that's what the people wanted. We said that this is how we do Pythagoras. We always label it C. Now, the other two sides, does anyone remember what were we labeled on? Harris?
A and B.
A and B. Does it matter which one's A and which is B?
No.
No.
Did I say yes?
At this point in time, no. And going forward in the future, technically no. So we've got a right angled triangle, we've got an unknown which is x. The unknown also happens to be the the hypotenuse in this triangle. Now the question is, how can we actually calculate this? In the last lesson I showed you how to count the squares and do that method, but this one we don't have squares. So what we can do is we can employ a theorem called Pythagoras' theorem. Pythagoras' theorem states that the square of the hypotenuse, the square of c squared, or the c squared, is equal to the sum of the squares of the other sides. The sum of the other sides is a plus b, but it's the sum of the squares of the other side. So it's a squared plus b squared. So Pythagoras' theorem states that the square of the hypotenuse is equal to the sum of the squares of the other sides. Now looking at this, it's a matter of substitution. We know that C is x, so every time I see C, I write x, so it becomes x squared. Every time I see A, I change it to 5. Every time I see B, I change it to 12. So I've got the equation x squared equals 5 squared plus 12 squared. So at this point, we pick up our calculators because we're going to do a few calculations here. Firstly, we need to go 5 squared. To be able to do 5 squared, we pick up our calculator and we type in either 5 times 5, or you can go 5 squared. I can go 5 times 5, or I can go 5 squared. It's up to you which way you want to go. Putting this in our calculator, what do we get, please, Jacob?
25. Which one?
25 indeed. And then, doing 12 squared, what do we get?
144.
I got 145.
Next, I have to add these two together. If I go 25 plus 144, what will I get, please, Annabelle? 169.
You have to use a calculator.
And therefore, I discovered that the square of the hypotenuse is 169. Now, we're not done yet. We've found the square of the hypotenuse. What are we trying to find, find?
The length.
The length of the hypotenuse. So to be able to find the length of the hypotenuse, what we're going to do is we're going to take the square root of both sides. This will undo the square. The square root of 169. I can simply go square root 169, or you may have to press the orange button for second function and then look for the square root symbol in orange somewhere around here. The square root of 169 is 13. The square root and the square symbol cancel each other out. So we get x equals 13. So how long is our hypotenuse in this one? 13 meters. We always write the units when we have units. If we don't have units, we write units. Like we write the word units.
That makes sense.
Are there any questions, guys?
If I was 8 years old and looking at it,
What's up?
It doesn't have to be good size. Like, does it matter if they're the same size, but I just write that it's 12? They're actually the same size.
I'm not following.
What?
I'm not following what you're asking.
Is it on that one over there?
Yep.
The triangle, one side's longer than the 12's longer than the 5. Is it okay if I put them the same size, just say one's 12?
Yeah, that's fine. It doesn't have to be to scale, because remember, you're always just going to sketch in your book. No rules for these. It's quicker,
Yeah.
and you'll get better at sketching as you get older. Okay, next one. A random triangle suddenly appears. This one's slightly different. One side is 9, one side is 5, and one side is y. When we're trying to determine the unknown side in a triangle, what should we always look for first in the triangle? What do you reckon, Hannah? What should we look out for first? Yeah, we always look to see if the triangle has a right angle. If it doesn't have a right angle, can we proceed?
No.
No, because this only works on right angled triangles at this point in time. So this one has a right angle, we're lucky, so we draw an arrow pointing out. What does the arrow always point to, Hunter?
The unknown.
The unknown, which is, in this case, C. It's not always the unknown though. We'll see that next lesson. It tells us where the hypotenuse is. In this case, the hypotenuse is an unknown quantity, y. Next, we label the other two sides, A and B. It doesn't matter which one's A and which one's B, Tegan? Nope. Now, we're trying to find an unknown in a right-angled triangle. What theorem could we possibly use to be able to solve for the unknown here? Any ideas, guys?
Right over there.
Grace, what do you reckon? Yeah, Pythagoras' theorem. Do you remember what Pythagoras' theorem was?
oh my god, what's that?
C squared.
A squared plus B squared.
C squared equals A squared plus B squared. Writing out the theorem, we then go in for the substitution. C becomes Y, A becomes 5, B becomes 9. So we get y squared equals 5 squared plus 9 squared. Next, we compute what we can. Y squared is 5 times 5, which is 25, plus 9 times 9, which is 81. And then, adding 25 and 81 together, we're going to get 106. Now, if these were squares, we would see that there would be 106 little squares here. But we want to know the length of one of the sides. So what we're going to do is we're going to employ our favorite operation in math. What operation is this, Hunter? The square root.
Yeah, lost.
Root it, indeed.
Yo.
Where's the square root? I don't have square root on this one. Where's the square root on this one?
What happens if it's a point for the
Whoops.
for the square root?
So we get the square root of 106. Now, Kobe is foreshadowing something. What happens if there's going to be a point in the answer? Well, funny enough,
Round it down.
this one has that exact same case. If we go the square root of 106, we end up getting not a clean number. We get an irrational number. We get 10.29.
Do we round down? Or just...
Lucas got 10.3.
No, I didn't. I said I rounded to 10.3.
Now you've got a choice here, guys. You can round up, you can round down, or you can just ignore. It's up to you. Rounding is not our concern today. I'm going to round up because 10.29 is closer to 10.3 than it is to 10.2. So I'd say it's 10.3. And what were my units for this one, please, Sailor? kg, which are?
That's how much
Kilograms.
That makes sense.
Kilograms. Why kilograms?
Have your body fat.
I thought Pythagoras' theorem tells us lengths. Focus.
But yeah, it tells weights as well.
I thought Pythagoras' theorem tells us lengths. How could it possibly be? Kilograms.
Tell us like technically.
Hunter. Focus. Any ideas, guys? Pythagoras' theorem, I thought it tells us lengths. Why are there kilograms here?
Because the kilograms is 5 kilos and 9 kilos.
Thank you for calling out. You're on the money. Because it could be the mass of something.
Could be that side weighs that much.
Yeah, exactly right. Pythagoras' theorem is not restricted to just telling us lengths, guys. We can use it in any number of applications, including weight. If you do physics in year 10, you're going to use triangle studies, so Pythagoras' theorem, to calculate weights on an angle. If you want to do physics at year 12 level, you're going to look at Einstein's equations and you're going to do Pythagoras' theorem on time. Interesting stuff. Okay, so what we've looked at here is how to calculate the unknown lengths within right-angled triangles where the unknown is the hypotenuse. We do this by first label our triangle, then secondly state Pythagoras' theorem, and then finally rearrange the equation in terms of the unknown to solve. At the end, we always write our units. If we have to do any sort of rounding, you can choose round up, round down, or truncate. It doesn't matter what you want to do. It's not our learning today. Our learning is applying this. Do we have any questions? Does this look like something we could do?
Yes.
That's what I like to hear.
Yeah.